Look at this picture. What do you see? Did you say the blue sky? The blue ocean? Okay, there's a lot of blue, obviously. Except for most of human history, it wasn't so obvious. The sky wasn't different, the ocean wasn't different, but the word blue just didn't exist. Homer, the man who wrote the two greatest works in Western literature, the Iliad and the Odyssey, described the sea as wine dark. He described sheep as violet. He described iron as violet. He used the word black over 100 times and white almost as many. He never once, not once, in either epic, used the word blue. Neither did the Vedas. Neither did the Hebrew Bible. Neither did the ancient Chinese texts. Civilization after civilization across thousands of years, on every continent, nobody named this color. It was the last color any human language ever found a word for. And here's where it stops being a curiosity and becomes something genuinely unsettling. There's now research suggesting that if your language doesn't have a word for a color, your brain may actually process it differently. You don't just lack the label, you may lack the perception. Welcome to the Airlearn Language Show. And here's what I find fascinating before we even get into the science. The fact that you're watching a video about color and language means that some part of your brain already suspects these two things are connected. That instinct is exactly right. And it's also exactly the instinct that makes learning a new language so rewarding. Because you're not just picking up words, you're gaining access to a completely different set of categories for the world. That's what Airlearn is built around. Not memorizing vocabulary lists, but understanding how a language actually carves up reality. Worth checking out. Links in the description. But first, blue. Let's start with a question that seems almost too simple to ask. How many colors are there? The obvious answer is it's a spectrum. Technically infinite gradations of wavelength from infrared to ultraviolet. But that's not how human minds work. Our minds categorize. We slice the continuous spectrum into discrete chunks and give those chunks names. And the names we use are not arbitrary. They follow a pattern so consistent across cultures that when linguists first discovered it, they could barely believe it. In 1969, two researchers named Brent Berlin and Paul Kay published a study that had taken years to complete. They analyzed color terminology across 98 languages from every corner of the world. Unrelated languages, languages from cultures that had never had contact with each other. And they found something extraordinary. Every language developed its color words in almost exactly the same order. First, black and white. Every language on Earth starts here. The distinction between light and dark, day and night. Second, red. Always red. It comes next in virtually every language studied. Third, either yellow or green. The order between these two varies, but they always come before blue. And blue? Blue comes last, almost universally. The very last basic color term any language develops. This is now called the Berlin-Kay color term hierarchy, and it's one of the most replicated findings in all of linguistic and cognitive science. The pattern holds across ancient languages and modern ones, across literature and pre-literature cultures, across almost every continent. Whatever is driving it, it isn't geography or culture. It's something deeper. So why? Why is blue always last? The answer that most researchers converge on is deceptively simple. Because blue is extraordinarily rare in nature. Think about this carefully. Red is everywhere. Blood, berries, fire, wounds, sunset, ripe fruit. Your survival as a human being depends on being able to identify red things. Green is everywhere. Leaves, grass, the living versus the dead plant. Yellow is everywhere. Sunlight, certain fruits, warning colorations in animals. But blue? True, naturally occurring blue. In things you can touch, eat, or interact with is almost nowhere. There are almost no blue foods. Blueberries at a stretch, and they're really closer to purple. No blue mammals, no blue reptiles. Blue flowers exist, but they're among the rarest in the plant kingdom. The sky is blue, yes, and so is the ocean, but you can't touch them. They're not objects, they're backgrounds. They're the canvas everything else exists against. Not something you need to name to survive. And here's a direct consequence of that scarcity. Blue pigment is historically the hardest pigment to produce. Ancient cultures that had every other color had to go to extraordinary lengths to make blue. The ancient Egyptians were the first civilization to synthesize a blue pigment around 2500 BCE, and making it required heating a very specific mixture of copper, calcium, and sand to almost 900 degrees Celsius. For most of human history, blue dye was worth more than gold. The ultramarine blue used in Renaissance paintings was made from ground lapis lazuli, a semi-precious stone mined almost exclusively in what is now Afghanistan. And it was so valuable that painters reserved it for the most sacred figures, the robes of the Virgin Mary, the sky and scenes of divine revelation. You couldn't see it in nature. You couldn't easily make it, so why would you need a word for it? Now, here's the part of the story that splits the scientific world in two. A researcher named Jules Davidoff traveled to Namibia to study a group called the Himba people. The Himba have a language with very few color terms, and crucially, they do not have a separate word for blue. Their color system divides the world differently than English does. Davidoff showed Himba participants a circle of colored squares. 11 of them were green. One of them was blue. To most English speakers, the blue square jumps out immediately. It's obviously different. The Himba participants struggled to find it. Some couldn't identify it at all. They could see the difference when directly comparing the squares side by side. They weren't colorblind, but without a word that carved blue out from green as a distinct category, their brains were automatically flagging it as different. The category boundary that English speakers experienced between blue and green simply wasn't there for them. But then, Davidoff ran the test in reverse. He showed the same participants a circle of squares, all of which looked green to English speakers, but some of which the Himba language divides into distinct color categories. And the Himba participants could spot those differences almost instantly, faster than English speakers could, who struggled to see any difference at all. Same eyes, different language, different perception. This is a version of a much older idea, one that has been debated for over a century, called the Sapir-Whorf hypothesis, or linguistic relativity, the idea that the language you speak shapes how you perceive reality. In its strong form, that language determines thought, that you literally cannot think a concept your language has no word for, is now largely rejected. But in its weaker, more defensible form, that language influences perception, that the categories your language provides shape how your mind naturally organizes experience. The evidence is increasingly compelling. And the color research is some of the most striking evidence for it. Because it's not just the Himba. Russian is one of the most studied examples in the color cognition literature, and for good reason. English has one word for blue. One. You can say light blue or dark blue, but these are modifications of a single base term. In Russian, there are two completely separate, unrelated words. Goluboy, light blue. Sini, dark blue. These are not shades of the same color in the Russian mind. They are as categorically different as red and orange are in English. And the cognitive consequences are measurable. Researchers showed Russian and English speakers colored squares and asked them to determine whether two colors were the same or different. When the two colors fell on opposite sides of the Russian Goluboy-Sini boundary, one clearly light blue, one clearly dark blue, Russian speakers were faster to distinguish them. Not just better at naming them, actually faster to perceive the difference. The linguistic boundary had been internalized as a perceptual boundary. The word had, in some measurable neurological sense, sharpened the eye. This is not a small finding. It means that the vocabulary of your language is not just a labeling system sitting on top of your perception. It is actively participating in your perception. The categories your language provides are the categories your visual system learns to use. Let's sit with that for a moment, because it has implications that go well beyond color. If two Russian words for blue make Russian speakers faster at seeing blue distinctions, what else is your language doing to your perception? What are the categories that your language has that others don't? And what has made you faster at seeing? And what are the categories your language lacks? The distinction someone else's language draws that yours collapses into one word? And what has that made you blind to? Every language carves up reality differently, not equally arbitrary ways. The Berlin K hierarchy shows that some distinctions are more natural than others, more universal, more tied to the structure of human experience. But within that, there is enormous variation. Languages differ in how they handle spatial relationships, in how they encode time, in how many emotional states they have names for, in whether they treat the self as distinct from the group. And if color perception is any guide, if the Russian blue experiment is pointing to something real, then all of those differences are not just vocabulary gaps, they're perceptual gaps. The speakers of each language are, in some subtle and measurable sense, inhabiting slightly different realities. Back to Homer. Back to that wine-dark sea. The classicist and philosopher William Gladstone, who was also improbably 4 times Prime Minister of Britain, spent years studying Homer in the 19th century and noticed the same pattern that would later fascinate researchers. He cataloged every color reference in the Iliad and the Odyssey and found the strange absence of blue. His theory was that the ancient Greeks were partially colorblind, a theory we now know is wrong. A better explanation, one that emerged from the Berlin K research, is simply that ancient Greek hadn't developed a word for blue yet. The color existed, of course. Homer's eyes saw the same sky we do. But his language hadn't carved it out from the broader field of the dark, shimmering, ambiguous hues. The sea was dark and moving and deep and alive, and wine dark was a better description for all of those qualities than any single color term could capture. It wasn't that Homer couldn't see blue. It was that his language hadn't yet told him to look for it specifically, hadn't handed him the lens. Ancient Greek did eventually develop the word kaianos, from which we get the English word cyan, although it referred to a range of deep, dark, shimmering blues rather than the clear sky color we now associate with the word blue. The category was forming. The perception was sharpening. The word was coming into focus. There's something both humbling and exhilarating about the story. Humbling because it means that however vivid and complete your experience of the world feels, it has been quietly shaped by the language you were born into. The categories you perceive as obvious and natural, the boundaries that seem to exist in the world itself, were partially put there by words, by your language's long history of deciding what matters enough to name. Exhilarating because it means that every language you learn is not just a new way of talking, it's a new way of seeing. The Russian speaker who perceives goluboy and sini as categorically different has access to a distinction that the English speaker's brain doesn't automatically make. The Himba speaker who effortlessly spots green distinctions invisible to English eyes has a form of visual precision in that domain that English simply hasn't developed. When you learn a language, you don't just acquire vocabulary and grammar. You acquire the perceptual categories that language has refined over centuries. You take on the lenses of everyone who ever spoke it. Russian gives you 2 blues, where English only gives you 1. And that's just color. Imagine what else shifts. That's honestly why I keep coming back to Airlearn, because it doesn't just teach you words, it teaches you the way a language thinks. And after an episode like this, that distinction feels a lot more significant than it used to. Links in the description if you want to try it. See you in the next one.